Hi, and welcome back to the Excel Simulation Showdown, Part 3, Correlating Assumptions. We're here with Frontline Solver's RiskSolver Professional 11.05. Our first step will be to go through the model, and the first thing I guess to go through the model is the parameters. So we're looking at a correlated portfolio returns model, and it's actually a very simple model. We start off with $250,000 that we want to invest, and we have a year's worth of daily trading data on 4 different asset classes. We have fitted the data of each one of these asset classes into its own unique distribution, which is over here. To calculate aggregate returns, we have taken the returns of each asset class which is being simulated and multiplied it by its allocation in the portfolio. So at any given time, this portfolio has only 25% invested in the industrial asset class. Then over here we have what we're all interested about, is the final portfolio value. As we know, it's quite important that we should correlate this, and we're going to experiment how we would do this in Solver. So as we know, we have already pre-calculated all the Spearman rank order correlations ratio or factors for this and generated our matrix. The complete details of our correlation matrix and the data that went in to do it is here. If you want to learn more on correlation, please listen to our previous article, Correlation versus Copulas. We did a video blog and we go through this more extensively. So if we come back to our example, what our objective is today is to figure out how to correlate with Solver, of course. And to do that, we have to create a matrix. And Solver has been working very hard on making this correlation process better. So some of the things that they've done that are kind of nifty is they've added this new dialog box which handily picks up the input. So we need all 4 of the inputs, and it basically gives us this nice graphical interface where, like Crystal Ball, we have this slider where we can play with it and see what the correlation patterns might look like. We can accept that, or we can actually hard code it by linking it in. So the mix of having the visual correlations with the actual numbers is kind of cool. I have to tip my hat to that. Now the other thing that they ask us is for a name. So we are going to call this the returns matrix, and we are going to locate it next to the other matrix over here, and we're going to hit save. So what we can see is that we have an unformatted table which has been inserted. So we're going to close this because we have the formats here. We can easily copy that, and we might even increase the size of the column. Okay, so this is our correlation matrix that we have reformatted. So another thing that would have been nice is if they had formatted the correlation matrix also. I mean, this is kind of useful, either with lines or colors or whatever it may be. And what we need to do over here is to correlate. Now, unfortunately, I was not able to select which side of my correlation matrix would be the one that I could edit. So where there were graphs which were on the bottom side, I have links, and I have to respect these. One other cool feature is the ability to turn on and turn off correlations. So the way you use this is that if you want to test how a model behaves, what we're going to do is the correlation is on, and we're going to turn that off, and we are going to run 50,000 trials using Monte Carlo simulation. So we have just finished running our trials. We're going to look at the values. And what we can see over here is that we have this wonderful chart where we can look at the various items of our distribution. As usual, we have our frequency, cumulative, reverse cumulative, and we have our sensitivity. So in this case, it's calculating, and we have two types of sensitivity analysis. We can look at moment correlation, otherwise known as Pearson's, or rank correlation, which we also know as Spearman's. We have this nifty little side panel over here, like we have in Crystal Ball and in Model Risk, which I find extremely useful because it consolidates all the information. You can look at the percentile data, and we can see that the P99 is at 344 and the P1 is at 227. We'll make a note of those numbers because we'll compare them when we run with the correlation turned on. Also, we have the scatter plots. So obviously we have these in the other packages as well. It's very clean, the colors are nice, though I would probably again put on the y-axis the fact that we're looking at the final portfolio value as it correlates to these various items. So this is the various charting elements that we have in RiskSolver platform. Okay, so we're going to close this, and that's fine. We'll save the changes, and now we're going to turn on the correlation. And we're going to run the simulation again. So now that we're running the simulation, it's run, check the model, and we are going to look at the answers once more. And we can see that the patterns in the correlation have changed. And of course, if we look at the percentiles, we can also see that the P1 went from 227 to 200, and P99 went from 344 to 371. So when we take into account the correlation, we can see that we have more risk in our portfolio. So this brings us to our analysis and rank or comparison of RiskSolver. How many correlation methods do we have? Well, we have one. It's the normal copula using what I'm assuming to be some form of Inman-Conover. They have one correlation function, which is used as the matrices. The correlation graphs are, well, we have Pearson's and we have Spearman's, and I guess we have the scatter, so we have three over here. We do not have correlation fitting. Multivariate correlation, yes, through the matrix. Correlation is done through the UI and Excel because we use the matrices, and we can also edit using the dialog box. And of course, if we wanted to just recap on how we would correlate two distributions together, the very first thing that we would have to do is to create a matrix by which we would add, and then, so that's one. Then we would have to populate it. So that's 2. There is a validation step. That's 3. And we'll just double check that. So now we see that it's positive definite. Had it not been, we would have had the ability to assign where it should prioritize the balancing of the matrix. So you can say, well, this one is priority 1, so give this, it has more risk in it, so increase the correlation. This one less, and that's how you can do it. So you can apply a certain amount of expert judgment when you're having it recalibrate the matrix. And then, so that's 3, and then of course when we insert it, and then so that's 4. So we have 4 steps to do that. Bear in mind that you have not included the fact that you need to fit the correlation, so all this work needs to be done using a worksheet like we discussed in our previous article, correlations versus copulas. So if you have any questions or you would like to learn more about this, don't hesitate to drop us a line. My email is etorkia, that's etorkia, at technologypartnerswithaz.com. You can visit our website, www.technologypartnerswithaz.com as well, or give us a call at 1-888-879-8440. Thank you very much for joining us for this presentation, and we look forward to hearing from you.